So in this video, I want to talk about two things. One is plotting in Python. Again, it's accomplished. There's like lots of different libraries that help you accomplish plotting. One of them, the most common one, perhaps, is called matplotlib, which itself claims to be a collection of functions that make matplotlib work like Python, at least this version of um, pyplot, I guess. So let's try that. So we need to do import matplotlib.pyplot, and we're just going to name it as plt, just like we named numpy as np. And then we can plot 1, 2, 3, 4, give y label, etc. But everything is preceded by what library you're um, using these functions from. You could just go matplotlib.pyplot.plot of whatever thing. Of course, that's too much. So we just go plt.plot. Okay. So let's try that. Import matplot. It completes it conveniently. It actually gives you this literal thing that we wanted to do. We're going to use pyplot. So we can go, I don't know, x equals 1, 2, 3, 4. Y equals, I don't know, let's make up some numbers here. 0.2, 0.4, and then we go plt dot plot x comma y, and then plt dot y label y, x. What else can we say? Let's see if the command title is there. Something. Hey, there it is. Okay. The plot appears here, which is kind of nice. And this kind of interleaving the code and the plot and maybe some text description is one of the sort of most useful aspects of Python, or specifically Colab or Jupyter Notebook, which is what Colab is based on, like we said. Um, so interleaving code, commentary, and then actual figures is very beneficial. Okay, so for your homework, what I would like is actually a notebook submission, which actually interleaves like the figure that you have, some code, and then actually some text associated with the whatever you're doing. Okay, so that it's documentation as well as the results. Very convenient. So that's plotting. Let's actually look at this thing. It also has plt.show, which is helpful. Okay, anyway, it ensures that it's actually shown. So the default is just these blue lines. Now we can use various, just like in MATLAB, right? Let's try. Let's see how far the MATLAB syntax goes. Oops. I guess it gives us all these formats. Are red zeros, and then maybe even that. Cool. We can see if this works. Line width. Doesn't work. Okay, so it's not exactly like MATLAB. That would actually work in MATLAB and increase the line width. Okay. Here, actually, it did a different plot or something. Okay. Okay, so it's not identical to the MATLAB plot command. Okay, so good to know. Um, and you can have different lines with different properties. I suppose you can go put a triangle, inverted triangle. Um, that should be good enough for now, I guess. Okay. Hey, this seems like a nice visualization. You can try to see what that is like. Plotting categorical variables with bar plots. You can do that. Controlling line properties. Looks like it does things. Let's try that. Oops. So it's similar but not identical to MATLAB's plot, right? So in MATLAB world, you would put line width within quotes and then go comma 6 if you wanted line width equals 6. Here it's a little bit different, okay? So you want to just go through things like this whenever you want to plot something. Okay, I can put text anywhere, just like in MATLAB, etc. So this is imitating most of the functionality of MATLAB, log plots, etc. Okay, so that's about plotting. Um, the other thing I wanted to talk about, which is a very important thing in um, using notebooks. So this is more of a warning, um, more than a positive thing. You have to be very careful using a notebook if you're using it for whatever more important reason. Okay, um, because you have the ability to run pieces of code little by little, you kind of lose track, in some sense, of what each variable potentially, what value each variable has. Okay, so we can go a equals 5, um, b equals a square, um, and something. Okay, I'm just going to do that, and then add another piece of code, and then go c equals, and then I'm going to say print b, and then I'm going to say c equals b times 2, and then go print c, and then I'm going to have c equals 25, or sorry, b equals 25. Okay. Okay, so this is a weird sequence of things. I mean, it sounds a bit silly to do this, but let me just show you what the danger is. Let me run this thing. And of course, it says print b is 25. Okay, so let's just make that explicit. It says b equals 25, or b is 25. Okay, so that's good. A is 5, b is a power 2, which is 25. Okay, all good. Now I can run c, and then go c equals b times 2, which is 25. Okay. Now I run this thing. Let me actually say b is not 25, b is 30 or something. Run it. Okay. And then run this thing and says, well, c is 60. Okay, so if you just look at this, b is 25, c is 60, you'll be like, what? C is b times 2, how can c be 60? And the reason why c is 60 is because in this later line, we've assigned b equals 30. and then we ran this thing, and then ran this thing. Um, and so when you ran this thing, this value of b was sort of active, and you said c is b times 2, which is 30 times 2, which is 60, right? So it's super important to realize that the order in which you run these things is important, and the state of your workspace of the various variables depend on the order in which these things are run. Actually, when I'm hovering over this, it tells me when this particular cell was executed right there, when this cell was executed, and when this cell was executed. Um, so it's it's important to realize that this is a danger, that if you ran things out of order, you will get sort of strange, nonsensical answers. So you have to be very careful to run things in order. You can run things out of order if you want, if you know exactly what you're doing um, intentionally. But ideally, your program should have a structure that needs to be run in sequence. Um, so all these cells need to be run in sequence for everything to make sense, I guess. So you can just go run all, then it will sort of run everything from the beginning, I guess. You can go restart runtime, which will clear all the variables, and then restart and run all. Will clear all the variables and then run all. That's really what you want to do if you want to run a program from scratch, because you're constantly updating variables here and there. And if you go back and run something, or if you skip a cell and run something later, you might have not quite the right values for the various variables, and that's potentially a great danger. So that's actually a danger with notebooks. So you want to be careful with that. Um, so given that all of you are already familiar with MATLAB, hopefully, or some programming language like MATLAB, hopefully this is you realize that this is an important issue. Um, Someone gave this whole funny talk about I don't like notebooks. If you want to hear sort of 56 minutes long rant about why this person doesn't like notebooks, you should um, listen to it. I think it's a pretty funny talk, um, and he makes some good points. But the primary danger, I would say, is this kind of out of order running. Okay, so you should realize that, and keep that in mind when you run things, and always make sure that eventually you run the whole thing and see that things are run properly, and the values of variables at various points are um, appropriate for where they are in the sequence. Okay, that's it for this video.